Welcome to homework.
Okay, so we've got an electron in a hydrogen atom, which is in the 3s orbital. And the question is, how many radial and how many angular? Learn to spell. Angular nodes exist. Well, we can start with radial. Recall that a 3s orbital is basically going to be the same shape as a 1s orbital, except for one important difference. So let's assume this is our 1s orbital. Well, a 2s orbital is going to look like the 1s orbital, except for it's going to have one extra shell of possible density. And a 3s orbital is going to have two extra shells of density, right? So anywhere black here is somewhere that an electron can exist, and anywhere white is where, let's actually say that anywhere white is where an electron can exist, and anywhere black is where an electron can't exist, right? So viewed from the outside, this would just look like a big sphere. But if we cut it in half and looked at it down, we're looking at that face right there, we're going to see that there are 1, 2 nodes, right? This is the first node, that's the second node, right? Those are radial nodes because they're nodes that are defined by distance from the center, right? So the rule for radial nodes is that you take whatever this number is, if that's n, you do n minus 1, and that's how many radial nodes you'll have. So 3 minus 1 equals 2 radial nodes. Okay, angular nodes. Well, s orbitals just don't have angular nodes, right? So recall the difference between, say, a 1s and a 1p. This right here, that spot right there, no electrons can exist there. That's referred to as an angular node. So p orbitals have one angular node. If we consider a d orbital, or one of the d orbitals, right, these actually have two sets of angular nodes. And f orbitals, I'm not very good at drawing them, but they have 3 angular nodes, right? So angular nodes, you can say S has 0, P has 1, D has 2, and F has 3. And if there were higher orbitals, which there are, but we don't often see them, it would have 4, and so forth and so forth. Okay, so a 3s orbital should have 0 angular nodes. Oh, not doing so good at the spelling today. Great. Most probable distance for the electron. So there's sort of an estimate you can make, and that's orbital radius equals n squared times the Bohr radius. So the Bohr radius is how far an electron is on average for the n equals 1 node, right? So a 1s orbital has a Bohr radius of a naught, right? This is the one. So if we're talking 2, then we're saying 4 a naught. And if we're talking 3, then the distance is 9 a naught, right? Because that's 3 squared times a naught. So what is a naught? A naught is, let's see, 0.529 angstroms, right? So 9 times 0.529 angstroms is, put this in my calculator, 9 times 529, 4.76 angstroms. And we did that with the formula radius equals n squared times a naught, where n is, the number, the principal quantum number. So, that's like 1s, 2s, 3s, S, and so forth. This is the N. This is the N. This is the N.